In this video, we're going to talk about how to curate and version your training dataset and hyperparameters in Labelbox Model. It is actually really important for ML engineers to manage all of the model inputs and model outputs in one place. The inputs refers to the datasets, data splits, and the hyperparameters you're using for each experiment, and the output could mean the model predictions, metrics. Having them all in one place makes it really easy to track and reproduce your model experiments and share your best knowledge among your team members. Lastly, it's important to compare model and hyperparameters to each other while seeing the model metrics difference so that you can identify the cost for different model results. Say you already have a dataset and project that's already done with labeling, and here we're looking at a multi-image classification example that classify an image between trees, mountains, and sunsets, and ocean, etc. So here, I would love to turn this project into a model training dataset. So to do that, I'm going to go over to the Models tab. I'm going to click on the Create New Model. I will give it a name, and here, the first thing we need to do is to specify the ontology. Ontology determines the output of the model prediction. What does the model prediction maps to? So here we're choosing the same ontology with the project, which is mapping to one of the scene classification that it has. And now I can create this model, and here I'm going to create a new model run. So a model run is refers to every model experiment, and each model experiment has its own versioned training dataset, data split, as well as hyperparameters. It will also be the place where you can log and upload your model predictions and metrics. So we would highly recommend for every experiment you run, you create a separate model run for versioning. So here I'm going to create a model run name as iteration 1. I can utilize the slider to set my data split. Here we provide a slider and input box to help you determine the ratio between train, validate, and test. So say I'm happy with the data splits, I can go ahead and create this model run. And here we have all the data. You could choose to inspect each particular split, or you can also use the model filter to select one of the class names that you care about for further inspections. Additionally, you will also be able to specify the model's hyperparameters for your training or inference purposes. Here we provide an empty template, but you can also fill them up with the values that you would love to for use in your model experiment. So I just fill in some values that I would love to use as hyperparameters, and now I can save this model config. Once saved, we will be able to export this model config either through this button here or via SDK. Similarly, with all of the data rows that you have, you will be able to export the data rows using SDK or using this download button here. It is worth noting that with every model run you created, the data rows and labels that you create is actually going to be versioned and frozen in time. That means even if you change your labels in the future, within this model runs, the labels are going to be immutable. And this is because you want to be able to reproduce your model results, and thus we provide the version dataset for this model run at the time of creation. So say I would like to create a second model run because I would love to try out a different configuration for data split or hyperparameters. I can easily do that with create a new model run, and here I can say iteration 2. And we provide some convenient mechanism to load information from previous model run. Say if I would love to use the same model run as before, model data split as before, I can load the data splits from iteration 1 model run. And similar story, if I would love to change only a little bit of my model run config, I can also load from my previous model run, and here I'm only going to choose the hyperparameters that I'm interested in changing. So now I will have 2 sets of model runs that's ready for me to run experiments on. So besides the UI feature, I would also love to talk about how can we do all of this model creation and more refined data curation within SDK. So here we hop over to this notebook that will be attached with the video tutorial. And here you can actually create a model run within SDK by simply using this command. And here we're going to walk through an example of a different way of curating your training, evaluation, and testing split. And here, different from what we did in the UI, which was using a slider bar to specify the ratio, in this example, we're actually going to sample 240 images from each class because one of the class only have 240 images. So we're going to sample the same amount to get a very balanced class representation. And for each data row sampled, we're going to use a random sampling to just determine whether it belongs to a training, validation, or test split, and with a random chance of 80, 10, 10%. So this is also, in this code, we're going to make sure that there's no overlap between the 3 data splits. So the first thing we're going to do is to export the labels from our project, and then we're going to specify each class contains a certain number of data rows from the project, and from this point on, we're going to randomly sample 240 data rows from each class, and then we're going to give them a random probability between 0 and 1 and use that to assign that particular data row to train, validate, or test split, and making sure that there is no overlap. So here is, this is going to be a random number because a lot of the number is random. So here I can see my train, validate, and test split is roughly around 80 by 10 by 10, but it will have variations, and that's okay with me. So after that, we're going to upsert all of the data rows, assign the data splits to training, validation, and test, and upsert all the labels attached to them. We also provide SDK to specify the model run configurations and hyperparameters. Here is another example config that I use. So we can simply define the config in a dictionary format and upload that to model run. And to export the model run data and config for your actual training script, all you need to do is to specify the model run ID, and from here you can export your labels, export your model run configuration, and use that to build your model and run your model. Last but not least, I just want to quickly touch upon how easy it is to integrate some other model tracking tools. Since the hyperparameters are stored in a dictionary format, it's actually really easy to integrate with some other training curve visualization and experiment tracking tools such as TensorBoard and MLflow. And here are some pseudo example code for you to check out. It's a really easy way to add your model configuration to hyperparameter callback for TensorBoard, as well as logging it in MLflow. We switch to a different model run where the model predictions and metrics have been uploaded after the training is done. You can easily see the predictions and metrics of this model. You can also compare it with a previous model run that you have created to understand their overall difference from their high-level metrics, as well as their detailed difference in predictions per data row. Additionally, you will be able to compare the model run configs between the 2 model runs, and hopefully this can help you understand what is one reason that's causing the difference of the model performance.